The Geostationary Operational Environmental Satellite Series, GOES, is essential to continuous observation of Earth's environment and plays a key role for weather monitoring, warning, and forecast operations in the United States and Western Hemisphere. Spacecraft and ground support work together to accomplish the GOES mission of providing data and imagery to public, commercial, educational, and scientific user communities. The GOES-R mission is expected to improve the quality and timeliness of information, enhancing public safety, protecting lives, property, and the environment, improving economic security, and promoting science, education, and research. NOAA operates 2 active GOES satellites to provide coverage of most of the Western Hemisphere. A third on-orbit spare is available in case of sudden breakdowns. Together, these satellites provide 24-hour weather products, monitor the sun and space environment, receive and transmit search and rescue data, and relay data from more than 20,000 land, water, ship, and aircraft platforms that collect information about the weather and environment. The next generation GOES-R satellites will usher in a new era for U.S. geostationary environmental remote sensing. With launch of the first satellite expected in 2015, the GOES-R satellites will begin a planned 10-year period of dedicated service to improve the quality and timeliness of weather and other environmental observations. Geostationary and polar orbiting satellites each have their own viewing strengths and limitations. What exactly is the difference between a polar and a geosynchronous orbit? In a geosynchronous orbit, satellites are positioned over the equator at an altitude of about 36,000 kilometers or 22,300 miles above Earth's surface. They orbit at the same speed as the Earth's rotation, making them appear to stand still. This allows geostationary satellites to view a feature of interest frequently and consistently, making the GOES system extremely useful for observing hazards like thunderstorms, hurricanes, fires, volcanic eruptions, and dust storms. A polar orbit is quite different. These satellites fly at much lower altitudes than their geostationary counterparts, typically about 850 kilometers or 530 miles above Earth's surface, and pass close to Earth's poles. A single polar orbiting satellite observes the entire globe in 12 hours, viewing most locations at least twice daily. Overlap by consecutive orbits makes high-latitude coverage more frequent, while the relatively infrequent coverage compared to geostationary satellites makes watching rapidly evolving events harder. The global coverage makes the data extremely useful for computer models that forecast weather and climate variations. Important comparisons between geostationary and polar orbiting satellites are summarized in this table.